We're going to look at partial sums of arithmetic sequences. Keep in mind that you can always do a partial sum by brute force, listing all the terms and then adding them together. If your calculator is allowed, you can use sum of a sequence and then put in the functional definition, the variable, the index start, and the index at the end of the index. But with arithmetic sequences, there is one other way to find a partial sum. So add the multiples of 3 from 3 to 180. Okay, so the multiples of 3 would be 3 plus 6 plus 9 plus 12 plus etc., etc. And at the end of the line, we'd have, let's see, 180, 177, 174, right? The multiples of 3. Okay, so I could just start to add those up. Well, I don't even have all of them listed, but I could try and add them up. There is a shortcut because it's arithmetic. Because this is adding 3 every time, it's like this is subtracting 3 every time. So what we get is this nice pattern. The first one plus the last one is 183. It is also true that the second one plus the second to the last one is 183. And the third one plus the third to last one is 183. In fact, every single pair of terms from the outside to the inside, if you keep moving in, will be 183. So we could actually say it's 183 times the number of pairs, right? Well, how many pairs did we get? Well, this is the first multiple of 3, yeah? This, let's see, since it's 3 times 60, is the 60th multiple of 3. So if I have from 1 to 60, that's 60 terms coming in pairs. So I have 183 times 30 pairs. Let's see, 0 on the end, 9. 3 times 8, 24. Regroup the 2. 5,490 is the sum. Okay, so let's add the sequence 12, 7, 2, negative 3 up through the 30th term. Well, first of all, let's establish that it's arithmetic. Otherwise, we have to list all 30 terms and add them. So 12 minus 5, minus 5, minus 5. So the common difference was negative 5. So we do have an arithmetic sequence. It would be defined by a sub n is equal to negative 5n plus, let's see, the term that came before the first one would be, I'm subtracting 5, I would add 5, 17. Okay, in order to use my pattern, I need to know what the sum is from the first one to the last one, yeah? So I need to know that last term. Well, the last term is the 30th term. So negative 5 times 30 is negative 150 plus 17, negative 133. So that last term was negative 133. This is sort of scrap work. Okay, so the sum of the first and the last term is negative 121. And if I were to, because it's arithmetic, that would be the same sum here and here and here, right, from the outside to the inside. Okay, if I have 30 terms, right, because this is my 30th term, and that was my first term, I have 30 terms, so I have 15 pairs. See, that's 5, 10, regroup the 1, 6, 0, 1, 2, 1, so that's 5, 1, 8, 1, negative, right? So negative 1,815 is the sum of the first 30 terms of that arithmetic sequence. What if it's an odd number of terms, so you don't get like pairs? Okay, I chose a very small number so that we could actually see what happens. So this is 8, and 4 is 12, and 4 is 16, and 4 is 20. Let's see, that's 1, 2, 3, 4, 5, 6, 7. 20 and 4 is 24, and 28, and 32. Okay, those are the 1, 2, 3, 4, 5, 6, 7. The first 7 terms. 8 and 32 is 40. 12 and 28 is 40. 16 and 24 is 40. And the guy that's not a pair is 20. 20 is half of 40. So 7, we would expect to have 7 terms, 3.5 pairs. We do. We have 3 pairs of 40 and half a pair of 40. So it's still going to work even with an odd number. And you may want to stop and think about that for a minute. Okay, what if it comes in this form? So we want the sum of the first 40 terms. So 40 terms, 20 pairs. Of a sequence defined this way. Now, I know that this is an arithmetic sequence because this looks like a linear equation, right? mx plus b, 7x minus 4. Okay, so I need my first term. My first term would be plugging in a 1, so that would be 7 minus 4, 3. I could start to list more terms, but I know I need my last term. So that's the 40th term in this case. 7 times 40 is 280. So 276. And I want to find out what their sum is. So that's 279. And I have 20 pairs of that. So 0, 18, regroup the 1, 15, regroup the 1, 5. So my sum is 5,580. Let's try an odd one. So if I have terms from 1 to 13, I have 6.5 pairs. My first term would be -5 plus 2, -3. My 13th term would be -65 plus 2, -63. If I add those together, I get -66. So I have 6.5 pairs of -66. So 6 pairs of -66 would be, let's see, 36, regroup the 3, 39. And half a pair would be -33. So altogether I have 9, 12, regroup the 1, 4. -429 as my sum. Okay, I have the first 20 terms, so I would have 10 pairs. Oh, wait. This is not an arithmetic sequence. So I cannot use the first plus the last times 10 pairs. I either have to list all those terms or I'm going back to sum of a sequence. And I'm hoping that this doesn't show up on a non-calculator piece.